Okay, now, what happens is this. In life, we always see data. And the data you see, if you read your notes, somebody made a statement. The statement says that the mean delivery time is 30 minutes. I try my best to write nicely. Mean, actually not bad, right, my handwriting. If I write very slow. Okay, the mean delivery, the statement says mean delivery time is 30 minutes. Now then, you say, why should I believe you? Mean delivery time of pizza, I don't know your Romino pizza, whatever lah, or whatever. Okay? See, it's 30 minutes. Then you say, hey, I believe you, don't believe you. In life, then we have to say, okay, now we will then use some data. Let's say, for example, you deliver 10 times, you deliver 9 times. You make an order 9 times. Okay? Then you take average and then make some judgment call to say whether that statement is true or not. Follow? So now, this chapter called hypothesis testing. What is hypothesis testing all about? Hypothesis testing is about using sample statistic. Right? Using sample statistic, which means that you're going to collect data, correct? To arrive at a decision about a statement. Now, what decision are you going to make? Which means the decision is about whether you agree that this mean is 30 or mean is not 30 or mean is greater than 30, whatever. Follow? You're going to make a decision. Based on what? Based on sample statistics, which means you're going to collect data. Which means you're going to order pizza 10 times, 9 times, 8 times, whatever, 50 times. So, suppose it's available in your lecture notes, by the way. Suppose. Now we suppose. Suppose we have a sample statistic. This sample statistic, we have, suppose, what we have is, on 9 occasions, don't ask me why 9, okay? Just example. On 9 occasions, you collect data, that means x1 plus x2 plus x3, 9 times. Your sample mean is 38.2. Okay, 38.2. How do you find 38.2? Actually, quite simple, right? 38.2 is like x1 plus x2 plus all the way to x9 over 9. So you collect 9 times, right? Yeah, that's no big deal. Then you say, okay, actually hypothesis testing is using this sample statistic to have a decision. Then what decision do you come to? Then you say, oh, okay, I know. This is 30. This is 38.2. We need to make a decision. Correct? Ask yourself, I collect this, then my sample mean is this. This is the statement. We need to make a decision. So now we need to make a decision. To make a decision. Alright? Is the mean delivery time 30 minutes? Correct? We need to make this call that we make. But then, how? Is it very far? No, quite far. 38.2 is quite far. No. Then the statement is wrong. Then you say, how far is far? How big is big? 37? 10? 36? 35? 34? Then we must be a bit more logical and more scientific about it. This whole chapter is about being scientific about making this judgment. Follow what I'm saying? Okay? Very good. So, just a quick answer. My quick answer is this. My quick answer. Actually, not very quick, but never mind. If the statement is true, if the statement true means the mean is indeed 30, if the statement is true, and assume that it is normal, and assume that x, where x minute is the pizza delivery time, is normally distributed with standard deviation nine. Now, this is a very big assumption, okay? This is a very big assumption. That means what we are saying is from long-term data, from very long ago, then we realize that we assume that x follows a normal distribution, and we know that the standard deviation is 9. We just don't know whether the mean is 30. We want to test. This is a big assumption. Later we will, okay, don't question this so much. I'm just assuming. Later in the calculation, in the body of the chapter, we will discuss a bit more on this. But let's assume, let's accept this for now. Now, we know that if x is normally distributed, and if the statement is true, that means statement true means the mean is indeed 30. Then actually x bar should follow a normal distribution. Can we recall x bar, if x has a mean of 30, x bar should have also a mean of 30. Sorry, can I check? Do we know what is x bar? X bar means if we collect data of 9 samples, x bar is x1 plus x2 plus x3 plus x4, all the x9 divided by 9. This is what we mean by x bar. Follow what I'm saying? Then x bar should have variance of 9 square over n, correct? 9. Follow? Then we can make some judgment call. Why? We can be a bit more scientific about it now. This is 30, the mean is 30, this is distribution of x bar. Correct? The distribution of x bar. After collecting the data, we realize that you get 38.2. Are we able to calculate probability x bar greater than or equals to 38.2? Can or cannot? Can, right? Okay, never mind, we calculate together. Correct? Normal CDF. Sorry. No. Wait. Yeah. Like that. Okay. Normal CDF. Then we say lower bound is 38.2. Correct? Then upper bound is E99. The mean is 30. Correct? And the variance is, standard deviation, Standard deviation is 9 square over 9, 3. Correct? 3. Correct? Standard deviation, Standard deviation 3. Then we get this probability, 0.00313. Okay, let's round to 3 SF, we get 0.00313. Follow so far? What is this all about? That means what we are saying is what we are saying is this. The area is 0.00. That's what we're saying. So my quick answer is this. I will declare that if the statement is true, means 30, to get a value more than or equal to 38.2, the probability is very small. Correct? It's very small. Therefore, my first assumption of mean equals to 30 is not true. Because it's impossible that not impossible, it's very unlikely that the mean is 30. Because if the mean is indeed 30, to get this extreme value of 38.2 is very small. The probability is very small. So I say, no, cannot. Statement, I will say, I will write this. I know some of you will dispute this. I will say the possible first. Possible conclusion. Statement is false. Why statement is false? Because statement is false because this is small. Possible. Now that's the intro of this chapter. Okay, let me answer your possible question. I know some of you will have this question now. Then you say, how small is small? Is 0.003 small? Is 0.05 small? Is 0.06 small? How small is small? Okay, the details we will find out in the rest of the chapter, but that's a very good question. Because we mentioned we wanted to be scientific. We tried to be scientific, we calculated a probability that if this is true, then to get this extreme value is 0.03. Then we want to arrive at a decision based on this probability to compare something. Then you have to make a decision whether how small is small. That's the main idea of this chapter. Correct? Okay? Very good, excellent. Now I've just completed the introduction only. Wow, goodness. Pause.